Hey everyone, and welcome to the chapter on natural gamma rays. This chapter will cover the principles and application of natural gamma ray tools used in wireline logging. Here you will learn about the fundamental concepts behind natural gamma ray logging, understand its key applications, logging conditions, and the physics behind the measurements. Well, we'll also explore the tools and methods used, as well as the calibration process. Let's get started. Natural gamma ray tools measure the amount of naturally occurring gamma radiation emitted by the formation. These gamma rays are produced by the radioactive decay of elements like potassium, uranium, and thorium, which occur in variable amounts in all formations. To be clear, these tools do not emit any radiation. There is no source in the tool. They just read the natural radiation in the area. And why do we measure that? Well, the primary application of natural gamma ray tools is to assist in determining formation lithology. Different rocks contain varying amounts of potassium, uranium, and thorium, which helps in lithology determination when combined with other measurements. Gamma ray tools also estimate the volume of shale and correlate log responses between wells. Let's talk a bit more about the importance of correlation. After an oil well is drilled, the first logging run, here shown in red, establishes the depth profile of the well. This initial log serves as the reference point. If subsequent logging rounds are needed, all of this must be adjusted or correlated to the initial log to ensure accuracy and consistency. In the image, we see a well being logged with the gamma ray curve plotted against depth. If we need to log the well again in the future, the new data, shown in green, must be aligned with the initial log, often the open hole, triple, or quad combo. This alignment is crucial for accurate comparison and analysis. This is important because wells often require multiple interventions over their lifetime. For instance, after the initial logging, there might be a need for a cement evaluation log or a perforating job. Gamma rays behave similarly once they pass through the same formation, and the deflection of the curve should correspond with the initial profile. Now let's discuss the logging conditions. Natural gamma ray tools are actually highly versatile tools and can acquire data under various well conditions, including open and case hole, and in any type of drilling fluid. Just keep in mind that these tools measure the total gamma radiation resulting from the decay of potassium, thorium, and uranium. For more detailed analysis of the specific concentrations of these elements, a different tool called the spectral gamma ray is used. However, for general purposes and in standard triple or quad combos, natural gamma ray tools are typically employed. To get into the physics of gamma rays, consider this as high-energy electromagnetic radiation emitted from the nucleus of an atom during radioactive decay. These rays are photons with no mass or charge, and they are traveling at the speed of light. Potassium-40, uranium-238, and thorium-232 are the primary elements involved in these decay processes. Talking about the decay processes, potassium-40 decays to argon-40, uranium-238 to lead, and thorium-232 to lead, each with their own complex sequences and half-lives. And these decay processes involve gamma ray emissions, which we measure to determine the presence of these elements in the formation. Natural gamma ray tools utilize scintillation detectors to detect gamma ray detection. When a gamma ray from the formation interacts with a man-made crystal, typically made of sodium iodide with thallium impurities, it produces a tiny flash of visible light. This flash, or scintillation, is detected by a photosensitive device, which then converts it into an electrical signal. These sodium iodide crystals with thallium impurities play a crucial role. When excited by a gamma ray, they emit a photon in the visible spectrum. This light pulse is detected by a photomultiplier tube, which amplifies the signal throughout a series of diodes, ultimately producing an electrical pulse. This pulse is counted as a single gamma ray, with the count rate proportional to the amount of potassium, thorium, and uranium in the formation. In tools like spectral gamma ray, the height of the electrical pulse can also determine the energy level of the detected gamma ray, allowing for a detailed analysis of the formation composition. When we see a gamma ray curve plotted in a log, we see that the units are gamma API. Let's understand this type of units. The gamma ray measurements is converted to engineering units through calibration. The American Petroleum Institute, API, developed a standard calibration method to ensure consistent gamma ray responses across different tools and service companies. Calibration involves measuring the count rates of gamma radiation in a test pit with known concentrations of radioactive elements. Here on the left, you can see the characteristics of the API gamma ray test. With this, the sensitivity factor is calculated and is used to convert raw measurements into gamma API units. For sure, count rates can vary due to the factors like the type and size of scintillation crystals, tool housing composition, and even minor impurities in the detector crystals, but still, a good working gamma ray tool will show the same responses every time it passes through the same formation. For anyone related with field operations, please know that gamma ray tools must be calibrated at the shop, verified it at the well site before running in the hole, and check again after logging to ensure proper functioning. So if you have the opportunity to assist in one logging operation involving a gamma ray sensor, keep an eye on the field calibration. A thorium blanket should be used before and after running in hole with the gamma ray sensor. In summary, natural gamma ray tools are essential for formation evaluation, providing information about lithology, shale volume, and correlation of geologic structure. Thank you.